In the beginning, there was nothing. And then, there was everything.
We all know that anything that occupies space and has mass is matter. It is composed of subatomic particles such as electrons, protons, neutrons, quarks, and other fundamental particles.
However, in 1928, while studying Einstein's theory of relativity and subatomic world, Paul Dirac's equation predicted the existence of antimatter. His equation showed that every electron has an identical twin but with opposite charge. He proposed that all particles have antiparticles which will annihilate each other if they come into contact. 4 years later, Carl David Anderson observed the track of anti-electrons which he called positrons in his cloud chamber experiment.
He observed the trail of particles similar to electron but in the opposite direction. This was the first known antimatter to be found.
In 1955, Emilio Segre and Owen Chamberlain first observed antiprotons in a particle accelerator called Vevatron.
Antimatter is basically matter with opposite charge and orientation. If matter has electron, proton, and neutron that make up the atom, then antimatter has anti-electrons or positrons, anti-neutrons, and antiprotons that make up the antiatom.
So in principle, you can have mountain and anti-mountain, moon and anti-moon, or universe and anti-universe. When an electron and positron meet, they annihilate, releasing their combined masses as energy resulting to the creation of photons and gamma rays. When the negative 1 charge of electron is added to the positive 1 charge of positron, this results to zero or no particle left except gamma particles with just zero mass and zero charge.
But what do you think will happen if 1 gram of matter annihilates 1 gram of antimatter?
The energy that will be released is more than the energy produced by the Fat Man bomb explosion.
Physicists believe that at the beginning of the universe, equal amount of matter and antimatter were produced, which annihilated each other after a few milliseconds. Why is it then that we exist in a matter universe? Recent studies investigate the claim that instead of equal, there could have been a very tiny difference between the amount of matter and antimatter produced at the dawn of the universe. In April 2013, scientists at CERN observed that B mesons decay more often than anti-B mesons. This violates the charge parity symmetry, which states that matter and antimatter should behave exactly the same, but in a flipped or mirrored way.
So why did the universe tilt in favor of matter over antimatter? The quest for the answer continues. Today, antimatter is used in the positron emission tomography. Radioactive sugars are injected in the patient's body, which accumulate in the tumor sites. When it decays, it emits positron which will be mapped out to locate the tumors. Someday, we will efficiently produce macroscopic amount of antimatter and contain it consistently, and maybe harness its energy once it annihilates matter to our citizenships so that we can boldly go where no one has ever gone before. To infinity and beyond!